Hi everyone, this video is for section 6.3 inverse trig functions. Unlike the first problem that we looked at where the inverse function was on the outside, notice that this problem has the inverse function on the inside of this expression. That doesn't necessarily change how we're going to approach it though. We will still start by working on the inside of this expression. So I'm going to go ahead and look at the inverse sine of 1/3. Bear in mind that if we were able to evaluate this, this would give us the tangent of some mystery angle that we'll call theta. But we don't have the luxury of being able to look at the sine inverse of 1/3 and know automatically, oh, this is a, 47.5 degree angle. So we technically do have the angle measure. We're saying the angle measure is the inverse sine of 1/3. And I know that that maybe sounds like I'm talking over myself in this case. But what we're going to do is we're basically going to break the mystery, okay? Our angle measure is presented to us as an inverse trig function, but we can break it in order to find the components that we need in order to evaluate this tangent function on the outside, which we know would be a ratio of y over x. So here is where the Pythagorean theorem comes in to save the day, as it kind of has for pretty much the entire time we've been studying trig. So if I do this right triangle, excuse me, recall that our horizontal value would represent our x, vertical would be our y, and then our hypotenuse will be our radius measure, okay? In this case, since I have a inverse sine here, the inverse sine reveals to me that my values are going to be y is 1 and our radius is 3. Okay, that doesn't change. Even though we're looking at the inverse sine, it's still giving us that ratio for a sine function. Because recall that the inverse sine of 1/3 is kind of equivalent to saying that we have the sine of some mystery angle is going to be equal to 1/3. So that's why I can comfortably identify still that 1 is equivalent to my y value and 3 is equivalent to my radius value. So at this point, we can go ahead and use our Pythagorean theorem here. Call that x squared plus y squared is equal to r squared. I'm going to go ahead and put in what I know. I don't know my x value, I do know my y, and I do know my radius. We'll go ahead and we will clean this up. 1 squared is 1, 3 squared is 9. I will remove 1 from both sides, and I get that x squared is equal to 8. I'll go ahead and I'll take the square root of both sides, and I get x is equal to plus or minus root 8. Now at this point, you usually would want to clean up your radical here, but let's save that to the very end. It might actually save us a little bit of a headache if we wait until the very end when we do our final presentation. But my main issue here now is that I do need to decide, do I use the positive root 8 or the minus root 8? Here again is where the inverse sine is going to leave you some clues. Recall that the inverse sine has a restriction, a range restriction, that goes from negative pi halves to positive pi halves. Okay, essentially that means that we are working in either quadrant 1 or quadrant 4. Take a look at the sine value that you have for, well, if we're working in quadrant 1 or quadrant 4, we need to think about our x values here. So let's just draw a quick picture. Sometimes pictures help. Okay, I am only working in here. So what does that tell you about your x values? Hopefully you're saying, well, they're all positive in here. So that means that my x value has to be a positive root 8. So I'm just going to go ahead and label that. Okay. Now we're done with the inverse sine. It's given us everything that we need. We know the x value, we know the y, we know the radius, and we also know the appropriate sines. Okay? So this leaves us with the following then. We want to find out the tangent of this mystery angle. Well, we know that the tangent is going to be y over x. Okay? So the tangent of this mystery angle is going to be y which is 1 over x root 8. I'm going to go ahead and rationalize my denominator to clean this up. This is going to give me root 8 over 8. And here is where I want to clean up my radical here. So cleaning up that radical will give me 2 root 2 over 8. I can reduce these outside numbers, so that's going to give me root 2 over 4. There is my final solution. The tangent of the inverse sine of 1/3 is equal to root 2 over 4. If you would like, you could check this in your calculator. Okay, but again, you're technically given the angle theta. It's just buried or presented to you as an inverse sine function. You use that inverse sine function to find all the components that you need in order to create the ratio that you know comprises tangent. I hope this was helpful.